Начинаем, да? Меня слышно? Так, здравствуйте, уважаемые коллеги, здравствуйте, участники первого международного конгресса транспорта и строительства. Разрешите вас поприветствовать на сессии «Новые технологии дорожного строительства. Как ускорить сроки и сохранить при этом качество и безопасность на наших автомобильных дорогах». И для никого не секрет, что ежегодно на автомобильных дорогах Российской Федерации, в том числе и Республики Башкортостан, увеличиваются скорости.
Good afternoon, dear colleagues. We are happy to greet you on our Congress. And here is the new topic, how to reduce terms but maintain quality and safety of road construction. It's not a secret that annually there are a lot of fatalities on the roads, and our main goal is not just build the roads but also to improve their quality and to develop our federation. Moreover, as it was said on the first stage, we have an ambitious goal to standardize not less than 85% of roads by 2027, which are included in the core road network. That's why it's necessary to apply innovational materials that will let us improve the quality of the roads, also expand the terms between the construction repayment, and also to direct the foundations to into new construction fields. And in our republic, a lot of building materials, constructive materials are applied, geosynthetics, and our republic is one of the first that started to apply the asphalt, the concrete, with the system of super pave. Those are different types of bonding substances, fiber concrete, and other materials. You know perfectly well about them. I also forgot about recycling. There's the generation of asphalt coating. All of these measures, first of all, as I said, are directed into improvement of the quality, and it also shouldn't be forgotten that nowadays, in condition of the economical situation, we need to focus on the Russian producer who is not dependent on the external economical situation. Thus, today, a lot of different reports, presentations will be given today connected with road safety, traffic safety, and construction, and maintenance of bridges with the use of digital twin and the boost strength of road foundations and surfaces. So let me give the floor to the deputy of the affiliate of the Cheboksary City office, Olga Gennadievna. Good afternoon, dear colleagues. Can you hear me? Actually, I would like to thank the Minister of the Republic of Bashkortostan and you colleagues for coming here today to really think and decide what is needed to be done in the road sphere, so that our roads being sustainable, stable. And what was said, that we need to try to get some money for road construction, not only for their repayment. And road construction is one of the top priorities in our federation. So my report today is not just about some innovative materials, but I would say that's about some efficient technologies for road construction that is applied to boost the strength of road foundations and surfaces. We know for a long time that any building, any structure, any road will stay as long it has a quite solid foundation. The better, the stronger this foundation is, the longer the road will serve. And also, I would like to add that today I've talked to some people. I realized we need to understand the goal that we have, and we need to take as a top priority is that we are constructors, road or any other types of contractors, and we need to build everything like for ages. Our roads need to satisfy us, not only us, but our children as well, for example. And I think that really this road construction sphere in any country, the following technologies might be really efficient. The technologies for foundations. What technologies may let us create some really strong foundations and maintain those roads for our siblings? First of all, there's soil strengthening. Also, recycling, regeneration of some layers, road layers of road clothes, and yes, it is responsible for the strength of the foundation and also the coating technologies. Nowadays, I'm talking about that the only correct direction that all the road constructors should follow. Those are asphalt concrete mixtures designed with some particular method. As it was already said today, the Republic of Bashkortostan was one of the first that introduced not super paved, but now we call it differently. That's the complex road design. And sometimes I hear some negative feedback of the system from road constructors, road builders, and they say that laboratory equipment is really expensive, but I really beg you to forget about the all those labs equipped for the old technologies. And if you had to equip them with new technologies, that would also be expensive. So, okay, doesn't matter what equipment you have, but there is some perspective. And I will tell you more in more details about those technologies, efficient technologies. Soil strengthening. Here I'm talking about the strengthening of foundation of roads, and the soil strengthening in other countries. Well, that's my dream as a road builder, that one day we'll have some standards and we will also be responsible for the foundation of the coating itself, because nowadays we don't have those regulation standards that the engineering design engineer would be able to apply for the foundation coating as well. Because all of that is connected with some simple stages. We cut off the topsoil, then uh, the mm, uh, the foundation is strengthened, then there is some part of a road is laid, then again the foundation is strengthened, and so on. So, and roads take a new appearance, and asphalt concrete mixtures are appearing in those roads because the top surface coating of those roads are different, and that's now the special layer of wearing off layer right now. Nowadays do not we are not really involved in that, unfortunately, but we can work with some road coating. And for soil strengthening, we use some mineral binding substance or chemical or complex binding substances. There are different types of those substances. Also, we add some organic and mineral substances mixtures. We'll talk about them a bit later. And very often mineral binding substance is the direct way to change the characteristics of the weak foundation. the foundation of the road, if we talk about the main part of the surface coating. Yeah, and we shouldn't be afraid to put any concrete layers on such a foundation, because we know that it's of high quality and good, so it will sustain for a long time. What else can we use for strengthening? Soil can be strengthened with cement or lime, especially these are some clay soils. And there are not really a lot of sand soils, but there is some lime soil, and it's oversaturated. So this material can be used for strengthening and dehydration. And some chemical binding substances are also involved here. There is some special direction, which is not really developed right now, and it's more developed abroad. But anyway, cement, concrete, and lime, really good mineral binding substances that can be applied for construction strengthening. And I would like to pay your attention that I came to you from Kazan, from Kazakhstan, and there is a company that very often faces some clay soil, and people in that company couldn't find a solution how to work with soils. They either oversaturated, water saturated, or dehydrated, and the soil one day can become very with high plasticity and not stable, so they didn't know what to do. And I suggested to treat them with some lime, and now they purchase all lime with their own funds, and they just strengthen all the layers soils with the lime, and the road becomes more stable with a higher quality. So when do we use such technologies and in the right way? We can use them when we have some regulations for soil strengthening nowadays. Apart from the existing regulations of cost 23558, cost 3491, or any other regulations, we don't have any other, only these. Before July 2022, we had some other regulations, PNST 322, PNST 321, but they are now being re-elaborated, but they haven't been taken yet. So if you haven't finished any projects based on PNST, okay, you can keep doing that. But if you're going to start new projects, you will have to use new regulations that are presented on this on this slide. There are also some additional regulations that about this technology. Something interesting that you can take. That's, for example, the
Это руководство по подбору и приготовлению нерудных материалов и грунтов, обработанных.
There are some additional books for construction, for coating construction and main automobile roads and so on, and also the instructions, the regulations for selecting and preparation of some non-core materials and soils. All of these materials are very, very interesting. The goals of application of strengthening and also stabilization of soil, strengthening and stabilization of soil let us distribute the higher load on the materials within bigger longer terms of exploitation. And surely the coating should have like one density, and the main idea is to get this stable foundation. The quality of any construction, whether it's a road or building, is a foundation, and the foundation is really important. The more density of the material, the fewer pores and voids it will have, because all these pores are the enemies of the building roads. Because maybe you noticed that if there are some roads with a lot of pores and not so it will be damaged one day. So to avoid all of this, we use stabilization and strengthening of soils, and yeah, that should be used in the right way. So the technology is really easy, but it's really sophisticated. So all the requirements to the application of this technology should be followed. How to apply this, what the amount of binding substance that should get into the soil, amount of water, because the optimal humidity should be achieved. We know that the density can be achieved only with the acceptable humidity. What type of materials can we use? That's pulverized fuel ash of fly ash of thermal power plant and slugs that are used in this technology, chemical reagents and other surface active substances and so on are also used in soil strengthening. What we need to pay attention to if we start working with this technology, there are some moments that should be paid attention to, and you need to answer to the questions of these moments. First of all, whether the strengthening of foundation is necessary for shortening of terms. For example, if the soils are over humidified, or we need the soil stabilization for the increasing of constructive construction. Why I focus on this? Because very often when the strengthening is foreseen during the design period, all of these factors are not taken into account, that we're not building everything indoors. Everything is being built outdoors with different weather conditions. When it's raining, it's all over humidified, and not only cement can be applied here, but also some lime can be used to dry up the material.
So, well, to work with the technology of strengthening of the soil, of course, we need to care about the size of this area. We need to think of the depthness of this. We need to know the type of the reagent which fits this territory. So we need. So only when we know all these rules, simple rules, we will get the correct, right technology and the very nice base. Of course, if we compare the traditional technology with the stabilization technology, so we have different layers. Yes, so we just sand layers, then gravel layers, and then 2 or 3 layers of asphalt. So what can we do? So we can strengthen the soil and then to place asphalt. Of course, the type and category of the door will be important there, but there are many variants. But these simple decisions they will allow us, so this picture shows us that this cake out of soil and out of gravel and sand, together with just, if we calculate and compare, but the depth will be like twice or twice and a half less. It depends, of course, on the type of the road and the intensity of cars there. And so this is a good substitution. One more new thing. So introducing of this norm, PST 9542, it increased the development of the technologies. So before this norm, everything went well with this construction, as you see on this slide. But now this won't be so easy to go. So we have very strong layers. So in the cost of the materials and the delivery of the materials are included. So this new PST norm involves introducing the soil quality up to the required level. So it leads to our using technology of strengthening of the soil, and then we can use the materials which we're working with. So what I wanted to show here, so people ask me, what does the lime do? It just doesn't only dry, it strengthens the material. And if it is used together with cement, it's a very good story. And again, I return to my point, if we work with clay and semi-clay soils, then we need to understand where to introduce lime. So where to introduce cement or lime, or to change the chemical structure of this material, and then to strengthen this soil. For example, yes, so M12, this is the road, everyone knows it, so I can give the example of it. So Moscow, Kazan, yes, so up till Yekaterinburg, we enlarge it. So there are weak soils, semi-clay, and the task was, according to the project, to strengthen it. So before strengthening, we've created the chemical materials that has the level of lime and cement, and we just introduce lime, and then in 24 or even 48 hours we introduce cement. Then we change the physical, chemical, and physical mechanical qualities of the soil, reduced plasticity, and after that we lowered the plasticity, and then we started using the cement, which started working as the good binding. No, and the lime won't stop its work. It's now connected with cement and will continue working. If we look under the microscope, we see crystallic and this crystallic cell. And if you see the cell, you will see this difference in these pictures. So, and now we see what lime does in such soils. So this picture shows us, for simple understanding, two examples. We placed them. One was strengthened, one was stabilized, and one was non-stabilized. So after water, so the materials, you see the pictures, it's just turned into a pile, but a stabilized one kept the form, and this will happen, the same will happen with the road. So here is the So you see that the level of soil, and we return to the strengthening of the soil. So if we work with lime, it must be specially performed about. So such lime has longest. So you see that using lime increases the quality. So then after the strengthening the soil, we need to introduce not only we need to introduce the soil itself, we need to control and check it. So control material things were done. So we need to reduce the hollows. So and then we need to control the density. So that there are express methods, as you see that there is a special equipment for express method. And what can we do to establish this road? So to commission this road. So we need to answer the question. So which day, how many hours do we need for the client to commission this road? So when you get the contract, you think it over, or you think the project over. This project includes technological cards. So your technological cards, according to the norms. So these technological cards must be, well, the information about the commissioning and the time limits for commissioning should be included into these technological cards. So which basis, on which basis, so you can just show it to this. Yeah, so you just maybe don't need to wait for 28 hours or 28 days. You may control the density and plasticity level. But if this soil is strengthened enough, this module will show the results practically at the same time. So this slide shows the effect of usage strengthened soils. This is a very bright picture of a real road in the Kolyma region. The soil, which is shown here and exists here somehow at some places of finding. So this is semi-permafrost, and it happens when the rain. So this picture shows what happens with the rain coming. What can we do? So we can stabilize it and make a very good base for the road. So just it is calculated the economical effect. Firstly, is a 30% economy in financing. Just you don't need to bring some extra material except for some binding and the equipment for introducing this binding. So we move on to the new technology. So regeneration of the road clothes layers. It's great that the Republic of Bashkortostan never surrenders and doesn't stop the work. And I'm involved into this project, and it's great that this work goes on. So a regeneration of the clothes. So we understand when we use it, when there is a road and we need to return it to the norms. Yes, so return it to the situation with normative thing. So in this situation, will allow the road workers to enlarge, so to repair the work, repair the road. So we use old asphalt. We use the base that it has. We work with some binding or complex binding or mineral binding, and then move on with this technology. And then we get a sustainable layer. So there are the documents. Of course, there is some problem in this PNST 306 that it stopped working in November 2021. But I want to introduce that we are talking about some state norms. So we're working on it. So they're working on in this field and in many fields. So they're doing the great job. So the tasks, there are a lot of tasks for us to stand. So when we, especially when the Western help stopped, now we need to work on ourselves. But old methodological recommendation never disappeared, so they exist. So you see these norms. So there are some life hacks, as I call it, that we may use in work. So the regeneration is the technology of refinding, rework of the old asphalt material. What is included into this regeneration process? So then we cut the layer, put it into pieces. Then we mix these components. So generally it's easy. The peculiarity of this technology is the rebinding of the monolithness, of being monolith of this construction, and it is required when the existing asphalt layers came into the state where it looks like the crocodile skin. So we see that the upper level is that's at that state that it should be taken out. So we can't just fraser it. Yes, so we just need to. So all this destructions of the road will appear anyway. So we need to work on it. So I want that regeneration and the strengthening of the soils both together. They need hydroisolation. We need some layer together with bitumen or some strong binding. Only then these technologies will work. I talk about it so that you understand, so that you don't think of this. So we strengthen the soil, so just that we can use it. No, we just need to hydro-isolate this layer on the top, because water will take into this territory, into this road, and then it will spoil it. So together with the regeneration, we may use cement, lime. So when the old asphalt, you take and you see around 7% of bitumen inside of this old roads, and of course it's wheel track of this such roads is big. So we can use lime. It burns bitumen. It just burns it out, so it doesn't make the material plastic, more plastic. Organic bindings for regeneration, everything that we have connected with bitumen and tars and resins. So complex bindings together with mineral, both mineral, organic, or even chemical.
And again, let's compare the volume. Here we have a typical construction of road coating within the major repair. There's the main soil coating, then the mixture of gravel and some and some crushed aggregate, and there is something like a pile of asphalt and concrete and non-fastened materials on the bottom. Pay attention to that. This regeneration recycling lets us achieve their strength, and thus we can lay 1 or 2 layers of asphalt and concrete. Again, paying attention to the type of the road and the intensity, what type of the road we need to get. But also, here's a tiny note: the regeneration layer shouldn't be thinner than 15 centimeters. Please, design engineers, clients, and everyone, pay attention that only 15 centimeters will work. Everything that's thinner will not, especially if some machine regenerations recyclers are applied here, because the machine with a low amount of the layer will not work properly. It won't mix that in the right way. Yeah, some people actually say yes, some people say no about the work of these machines, but they agree that this is the optimal 15 centimeter layer that we need to maintain. Talking about the selection of recycling materials, we face the fact that when people start selecting this, there's a question: how much new material should be added, how much bitumen or cement should be added there? Well, actually, everything is really easy. Especially for this presentation, I divided the whole process into stages. First, we need to understand the thickness of this package. We should analyze the site with estimation of asphalt and cement that was applied earlier. We also need to understand the places for samples and take some drill samples. We can't take those drill samples or core samples along the axis, because when our presentation will finish, you can take these slides and to understand these stages for yourself, because I think here they are written in the very good detail. Also, you can see the amount of bitumen in the samples and how many crushed aggregate was remained in those samples, and also the amount of cement material can be also understood. So people always ask me about that, so that will be a really good manual for you. There is also the estimation of necessity of binding materials and the amount. First of all, we take some inert aggregate, we decide what we need to add there, and then we get the understanding of the best way of introducing the type of the binding material, because sometimes when there is only about 7% of remaining asphalt or bitumen, we shouldn't add too much, because a wheel track already appears, so we need to get rid of some material, so we should be attentive. One more thing: regeneration or recycling, stabilization, strengthening soil. The flatness of the surface is the basis for the strength, for the solidity of the below level layers, because in the picture you can see the perfect surface, because if it's different, when cars are driving over the surface, some distraction appear on the top surface and everywhere. So the flatness of the surface is very important. Also, organic mineral mixtures are very important as well. In our country, organic mineral mixtures are not applied, are not widespread in application. It's very sad, because I worked in the I worked in the northern part of our country, and when I came back here, I saw that here this technology isn't really applied, and it's very good. There are some regulations like GOS 3491 and BNST 632, which are written very well. Also, BNST 306 also refers to this type of technology, and all of them are really good for the layers or foundation, especially the top foundation layers, and they work very well for in terms of flexibility and everything. And if we talk about compression, it also works perfectly well. Here on the slide, you can see different materials that are used for organic and mineral mixtures, but when we select the materials for this mixture, we always need to add some bitumen emulsion, bitumen binding, because it included into this type of mixtures after we hydrate the material, because very often we get some negative feedback of this technology just because in the first stage some basic rule is violated. So we need to introduce this emulsion only into the hydrated, moisturized mixture. Here in the picture, you can also see some lab samples that are being prepared, and also some in some works. Production words. Here are different types of recyclers that also provide some good emotion and everything. And the most important thing is comparison again, where it's better to apply this everything, these mixtures in the constructive layer. Usually organic mixtures are applied under the asphalt concrete layer according to PNST 542, and also it helps, this emulsion helps in burning of the destructive load, burning of this destructive layer for the foundation. And if this mixture also consists of the strengthened soil, that will be the best solution for the road foundation construction. So nowadays the Kazan, Yekaterinburg part of the road will be built with this type of road coating construction. We've agreed on that. And one more important thing here, all the materials and technologies that consist of cement active binding substances should be treated in the right way. The material, the layer should be covered to avoid the dismissal of water, because if it dehydrates, the mixture will stop working. And it prevents you from getting the necessary characteristics of the layer, or maybe some application of bitumen emulsion, for example, or any other strengthening material. And we're moving to the last but not least technology that I think is really efficient for construction, is the volume constructive design of construction mixtures. That's some kind of feel for road constructors, for clients, road builders, that will help us to avoid wheel track someday. And if this peel is on a very strong, solid foundation, we will finally stop repairing, but we will start constructing. That's what we really want. Those asphalt concrete mixtures that are designed with this volume method have the following advantages. In labs, when we compact those samples, we reproduce what's going on the road, because all this temperature compressors reproduce all those compactions of different vehicles, road vehicles that follow that. Everything that we compact, they are bound to all of those to the all the exploitation parts. Also, the control of everything can be implemented online. We don't have to wait for the lab results of those drill samples and so on. Also, we can understand the climate zone, not just looking some special table, which kind of material or something like that, regulation we need to use. But now we can understand the exactly what type of material beating we need to apply in a particular climate region. Also, now we can understand the transportation load for design of asphalt concrete mixture and so on. And we will now be able to understand on the lab stage of the selection stage, we will be able to understand how this road, how this asphalt concrete will work within 20 years. And this system will accurately show us whether this type of mixture will sustain this period. Nowadays, we know that we love what's going on right now, maybe too much, but we should get to the new technology. We understand the porosity and everything for a 20-year period. But now I would like to ask you to take tests for water resistance in labs for these when you do this type of technology, volume technology, because you can't avoid this test. Sometimes you think, yeah, I may not do this test because I will understand everything anyway, but no, please do that test and don't lay any concrete without this water test, please. And also we have very simple equipment for checking the type of materials and everything. And the most important thing that we need to understand is the characteristics of volume fillings. Why we need to work in this volume functional design? And well, the picture is really simple. Here's the grain content, stone to stone. Medium is working really thin films, and it burns down and sends everything to the bottom layer. But when we work with the A-type of the grain size composition, we see there's no frame material and it doesn't have the appropriate material.
Таких смесей нужно в первую очередь, конечно, заниматься и лабораторией, и АБЗ.
So of course we need to pay attention to the quality of concrete quality, and when it's being issued from asphalt concrete mixing plant, we need to pay attention to the quality of roads, and we need to pay attention to the culture of labor and work. When people will start appreciate their labor and their work, all the roads will become really good and of high quality. The quality control, incoming quality control is really easy as well, and it let us observe the increase of density online, and it influences the quality of the laying as well. We don't have to wait, we don't have to worry. That's great. So thank you very much for your attention. Thank you.
So, Olga Gennadievna, thank you very much for your intense and informative speech. Of course, we are out of the time limit, but this topic is very interesting. So what I want to say about this, that we're very grateful that we are in trend, that we start producing this asphalt concrete mixture. So when we still move on in this field, so it's very nice that there is UFA on your slide because we're here. And I would like to say furthermore that we need to stipulate to stop using some norms, of course. So just we can't forget about the type A. Maybe some roads need type A. Some road arteries need this technology of super pay. So all this, it's important to understand that the main load is from the wheels on the top layer, but this load is on all layers. It's distributed on all layers, and this wheel track appears on this, not only on this top one. So I want to stipulate that unfortunately, first we talk about innovative technologies, and then we change innovations, we restart innovations, and but there are some so progress doesn't stop, and we just new technologies perform new tasks for us. So we just it won't work enough. So just we need to talk thoughtfully about this. So dear colleagues, do you have some questions to Olga Gennadievna? So then let's move on, and we give the floor to the head of the department, head of the information modeling department. So Nikita Golubev, maintaining bridges using digital twin. Hello, dear colleagues. First of all, thank you very much for giving me the opportunity of being here. I represent organization Гиперстроймост. We have a lot of objects in the Republic and in Russia and beyond Russia. So we talk about bridges with the use of digital twin. So digital twins are used widely in aviation and machine construction, and together with the abilities of scaling, it appears in the construction area too. So I want to say that we don't have so much practical experience in building twins, especially when we speak about the transport infrastructure. And the point of my speech is to introduce you with this concept on the example of a bridge. I am determined that this concept can be used for roads too. So we just talk about what digital twin is. So then digital twin from the point of the bridge maintenance, how it works, and various of usage such twin on the realized project in Germany. So the maintenance of bridge includes different events which lead us to the sustainability and long life, and the maintenance of bridges so that we may find defects faster. So the master has the complex surveillance, so visual, the periodical, special, and diagnostic ones. So all these look-throughs are collected into one data when the planning of the reconstruction starts. Traditional practice has some drawbacks. First of all, this is such works on surveillance they happen at some stated time, and the technical has the surveillance has reactive character. So the repair work starts after finding the damage. So also we have this handing methods. Then the documentation can be kept in different and hard-reaching places, and the documentation doesn't have actual data about the factual breach condition. So, and the documentation is in the paper variant. So modern technologies can't be used here. Then our experience, then the experience in exploitation period, so we use in projecting new breaches. But this could be help the sustainability and safety of such constructions together with our experience. So according to the analytical report, the consulting company made this research, and it was shown that the usage of paper data on the exploitation level, it enlarges the funding on 10 to 17%, which is a lot. So then, to solve these problems, so digital twin can help. Digital twin is that physical object is synchronized with a virtual one, with its copy, a digital copy in the real-time measures. And together with this two-sided information interaction, so this object, whatever it is, a car, a bridge, or a plane, so it just exists in two worlds, a real world, physical world, and the digital one. So according to the maintenance of the bridge, the point of the digital twin is to integrate different data coming from monitoring systems, from classical looking throughs, from intellectual transport systems into the digital model of the bridge. So this bridge, this digital twin gets new information, uploads new information, and we always have some actual technical documentation in 3D of our physical object. So creation of digital twins begins with the digital model according to the state regulation given here on the slide. So this planning starts to be obligatory since 2022. So for the construction made on the federal budget. So strategies of digital building, digital development. So our institute uses the information modeling, and together with this model, we have the project for a lot of different objects. So together with in Moscow, for example, we have just Moscow bridge above the Moscow River. So we need to pay attention that every element of this model has the characteristics of a physical object, but this model doesn't have data about the real moment information. Yes, so it's just a digital model, it's not the digital twin. How the digital twin works? So 3D model is included, so which it is used with some special software, and the base database are in some, no, there is a special database for that, so it includes the data about from two sources. The first source is a classic look-through and a classic variant of diagnostics. So then semantic and digital information goes, geometric information is reflected in the digital information. The second source is the monitoring system, which is also represented in this digital model in 3D dots. You can see them on the screen, how it looks. So these objects have the characteristics of some data sources. So all the data is consolidated on the databases. So in the informational model are connected with the database together with the unique ID. So we just can see the whole information about the accurate information about up-to-date condition of the bridge. So I would like to show you the example. This is the realization of the digital twin. This is the bridge in Hamburg in Germany. So the administration of port in 2019 started the project called Smart Bridge. The point of it was to create this digital twin of the bridge, and this bridge is works for a long time. So the twin was made for the existing bridge. So there is the platform which allows to visualize to measure 2D or 3D modeling. So then the level of the whole bridge is a model for that. So there is the information card there, which shows the general technical evaluation of the layer. So we see that this is 2.8 and it's in the green area, yellow area. The information about the accurate condition of the bridge can be divided into different topics and fields, dates, injuries, transport, diagnostics, and the monitoring system data. So the condition is shown through the indicators, which are used on different levels of this bridge. It's difficult to say it into words in presentation, but just you can ask me just afterwards. So it looks like this. So the damages look like this on this model. Every damage has its own indicator of this different color. So we see the indicator 3.2, which is in the red area. So it shows that the master should pay attention to it. So this damage goes together with the base part of this bridge. So master can find it in the intuitive sphere and find the whole information about this base. When it was built, what temperature, what damages it have. So together with this objective data to have some measures required to solve this problem. So it looks, the localization of damages looks like this after the diagnostic work. So in the end, I would like to say that not only Western colleagues work on it, our institutions work together with different companies like Traffic Data and InGIFRO. We work together, we test this technologies, and it will help together with traffic data program to get the information about the traffic level. And this monitoring system will help us to introduce the actual condition of the construction elements. And with all this information will be consolidated in one program and show on this digital models, which we develop in our institution. This is this mixture of different companies will allow us to create the digital twin in practice. So this was the digital twin in practice, so in bridges on the stage of exploitation. So we've looked through some steps to come from reactive to prognostic maintenance. We need to enlarge this model so that it can be used freely and openly. So when we say that this concept can be used for any object of transport infrastructure, thank you very much.
Thank you very much, dear colleague. I'd like to say that Dnipro-Stroy Most is one of the hugest constructors in the Russian Federation, and they design some bridges even in Ufa. And I have a question. Could you please tell me what software you use for this 3D design and those informational models, and how are there any local substitutes for that, not some foreign softwares and everything? Yeah, you're talking very beautifully about everything, and you attach some foreign experience, but are there any local Russian examples? Well, no, nowadays, no. Nowadays, yeah, we collaborate with Gipro traffic data, and we have very good local softwares that are responsible for road construction. But if we're talking about some bridge construction, that's the situation is not very good. We can't substitute a import right now. So, well, that's all for the future, right? Nowadays, the digital twins are our future. No projects in Russia have been realized yet, but that's all for the future. Dear colleagues, do you have any questions?
То есть по мостовому сооружению
So
расставляется...
talking about bridge construction, there are some markers, and using some video observation technologies, all those shifts and stretchings can be observed. So that's what you meant? Right. All those benchmarks and detectors are installed on the bridge, and they can observe and control the information and send that online to create this 3D model. And this 3D informational model helps to navigate information very fast, to understand intuitively where the detector is located and what's going on. So, do you mean some electronic detectors, or, for example, if we put just benchmarks around, and maybe we have some video camera which is coordinated, all the benchmarks are coordinated perfectly well, can we observe this reaction, these changes? For example, the color changes of some surface that can also be estimated and observed automatically. Yes, that's right, absolutely. And please pay attention, this traditional approach doesn't disappear. They like add each other, all those traditional observations, human observations, where special specialists just go and check everything. It just is a good addition for this digital twin system. And as I said, all the speed, intensity, and everything you can see in that digital twin as well. Thank you. Yes, I have a question. So now you're creating the software for digital twin, and that's the future is behind this. It's really great, and we'll try to achieve that. And I think we'll reach this result very fast. But on your slides, there is some estimation of the program. That program can estimate something like there was yellow zone, the 8.2%. So there is some regulation. In America, they have their own regulations for those damages, and here we don't have those regulations. Well, I know that you have some manuals, methodological regulations, recommendations for that. Only them they exist, but there are no regulations. So probably you can start doing that work as well for creating those regulations. Probably. Thank you. So today we've discussed some innovative materials and design. So now we have only one question remaining, but it's not least. So yeah, we have good roads, we introduced new materials, but unfortunately the amount of road accidents doesn't decrease. So for all of these measures, reasons of car accidents and events to reduce lethality, Azamat Hamatulin, head of Department of Bashkir-Do Transport Project Design Survey Institute, will speak. So thank you very much, dear colleagues. I want to ask the question to the previous speaker, but I didn't have time, so I will start. Today I wanted to talk about social risks rates and to analyze the world practice, whether this goal is achievable in Russia for reduction of lethality. So let's start. World practice shows that social risk in 2017 lethality of for 100,000 people, there was about 13 people to 13 people. And yeah, sure, we close to Uruguay or Argentina, and yeah, the best results in Norwegian and so on, of course. What we've reached in 2020, according to the statistics. We have we have less, only 11 deaths instead of 13. I don't know why the United States on top, so maybe the statistics were wrong. And the best results are in Norway and Sweden and so on. If we compare two results, we can see that Norwegian had the result of 2 and now it's 1.8. So their result is not that great. Here in the picture, in the graph, you can see the statistics between 2020 and 2030. And those countries that started this way early, how they achieved this level. So there was a very intense decrease, and then something happens to the system, and it's more difficult for it to move further efficiently. And in Russia, we see like in Russia, their indicators are a bit different, and we'll have to achieve them. Okay, one more slide. In 2021, the lethality rate was actually decreased, and that's really great. Yeah. So short remark, well, probably this is not the latest presentation, unfortunately. Road services, police services are always responsible for road safety and everything. But in the local law, administrative law, we can see that the administration, local administration, is actually responsible for road safety, not only the police. So again, the responsible people, there are one responsible people, but the other people like are asked for the results and everything. So we'll see. Let's have a look at the figures that we are achieving. we've been achieving for the latest years. We can see that in our republic for 2021, the social risk rate is 12. It's a bit more than in whole Russia, and there are some regions in Russia that are more successful. And within our region, in Ufa, the social risk rate is very low, 3.8, so it's very close to standard. So maybe not in Ufa, but in some other regions of our republic, these measures should be taken. So we'll consider that. Here we can see only figures, and that's it. The lethality for 100,000 people was 841 among our republic, 44 people in Ufa, and Kushnarenko district showed us a very huge dynamic of 20. So we need to analyze that, what really happened there. We need to elaborate and focus on that, look closer. So what we suggest, what's my opinion? The presentation wasn't updated really, but okay. So we need to conduct some research within the Republic of Bashkortostan and Russia. More, they should be deeper, should be more detailed, and there are some special units, institutes that can do that, and all of that data can be checked on the internet. So but that's just statistics, why it happened and how many accidents really took place, but there are no recommendations. So what do we need to do to achieve good good rates, satisfiable rates of lethality? So there are different units responsible for that, municipal and administrative and everything. Yeah, a lot of recommendations, but what to do? So we suggest to run a survey, conduct a research and analysis. We need to analyze the roads and the characters of those accidents. So we should run a horizontal and vertical analysis, and on their basis we should deduce what we need to do, some local measures and regional measures and everything. So I wanted to show in my presentation the example of local measurement that we held on the roads of Republic Valley. So okay, but that's another presentation. So what we need to do, we need to elaborate, work through that, and in that case we'll be able to reach the social risk rate that should be achieved by 2030. Thank you.
Thank you very much. So to analyze your table with the death rate, so is it connected somehow that the car traffic increases with every year, and the statistics, the biggest amount of cars is in Ufa? So just the less cars, the less accidents? No, of course we need to analyze this too, because can you show us the table, or is it over? So the level of the social risk in Ufa didn't change much. It increased a little bit. We had 3.2, and now we have 5.9 was in 2015, and in 2017, 4.2. So then when we started working on it, so the first repair work started in 2018, and then the level of death rate increased. So then in 2018, the social risk level decreased rapidly. So what do I mean? So in Ufa, the dynamic is not very different. Yes, of course, there are more cars, but the numbers are approximately stable. So, but when we talk about regions and districts, we don't know much. So even when we are on commissions, we react, of course, on what had happened already. All commissions on the federal, Republican level, on different levels, in city levels, all react to what has happened already. What we need to look forward about future, what to do to stop this so that it doesn't, these accidents don't appear anymore. So I agree with you totally. So we need to look for places of the big traffic. We need to investigate, research it, and then to provide events so that these accidents don't stop. So what's that? Is that a road situation, climate situation, or a human situation? So all these unpleasant things. So just do you have questions, dear colleagues? So since we don't have any questions, so being a moderator, let me conclude. So renovations. Without renovation, we can't move on in this door construction sphere. So first, by using new materials, we will enlarge the quality and decrease the financing. But we should never forget about the human rule, yes, so the human factor, because we need to work on so on these works according to the technologies. So our labor should go on for many years. Thank you very much for everyone. So have a good day.
Никит, а у вас же этот, приветствую, на прошлых семинарах вы видели, знаете? Полезное дело. Спасибо.